Hello. So we are waiting for somebody. Can you guys hear me?
Hi, Jimmy.
Yes.
Good evening.
Fine.
Good morning.
Morning.
I'm not sure.
Can you hear me?
Yes.
Chunjin is another meeting, and I'm not sure Yahweh will join or not. Maybe we can wait 1 more minute. So
I think Yahweh is on vacation. I think we can start.
Okay, great. So I proposed some topics, and if there's other topic, then I would like to introduce the light definition, because we removed some optional attributes and also defined the alarms, and I haven't got enough feedback on the alarms, so I want to first go through the OTI definition first. Then because there were rounds of discussion in the email thread in the discussing about the high level design, and I think we made some progress, and I would like take this chance to introduce the progress on the high level design, and also the plans to how we can move forward in this SONiC OTN group. Is it okay?
Yeah, I think we can. That's a good topics. Yes.
Okay, let me how to share my screen. Yeah, this one. Can you see this? Can you see the screen? Can you see my screen? I'm not sure if it's working.
Yes, I can.
No.
Because
I cannot see your screen.
not sure, because I'm enjoying the meeting with the web. Let me try again. This one. Does it work?
You can just see the browser.
The browser, right?
Yeah.
Yeah. I think that's that's it.
Okay.
I joined with the browser. Let me switch to the definition first. I think you should see this Excel, correct?
Yes.
Because we received some feedback on the original OTI definition, that it contains so many attributes that are not defined in the OpenConfig, and we think that there are some optional attributes which may not be necessary at this stage, because we think that we can make the OTI, maybe the version 1 working first, then different vendors can contribute the other optional attributes, then we can move forward. So I remove all these optional attributes out, and just keep these green and the blue attributes here. So the blue attribute is I think is the index to create the OTI objects, but the blue ones are the attributes that defined in the OpenConfig. So I think these attributes, I think, is much easier and clear for everyone to understand, and then I think the objects is the same as the original, which is already submitting the GitHub source code. I think these, but I keep some attributes which are not defined in the OpenConfig. I think these three, because I think these ones are required for the OTI framework keep to work, because such as the line card type, because we need this attribute to distinguish which kind of line card it is, and then the alarm notification, which is the basic alarm notification callback for line cards to report the raw alarms, and also the state change notification. If the line card plug out, then it should report the line card is plugged out, or there is a communication failure. Then we need this notification, and because there is some business logic and in the OLSS and SYNCD to handle the line card status change. So I keep these three definitions, and all the other ones are the OpenConfig definitions. Oh, by the way, the OTDR, because there is no standard OpenConfig YAM model in the community, then this implementation is based on the Alibaba's OTDR YAM definition. So I think it's common. It's common. If no one don't agree with that, then we can go with these definitions. So these are all the OTI objects and the definition for the OpenConfig YAM model. And we hope that at the first stage, we will implement these attributes in the SONiC OTN first. Once these attributes are working, then we can then we can move on to define the other attributes which might be necessary for an OTN device, such as the I don't know, there are more features. Maybe these are the vendor specific features definitions. Then we can expand our OTI definition in the future.
So
So
wait, can you go back to have about two quick questions? So for the line card, do we need a line card ID? So seems not here. It's a multi-ASIC. Do you need an ID for that?
Once you create a line card, then the OTI library will return the line card ID to
Oh, I see. Automatically.
Yeah. But the other ones, they might need to pass the parameters.
Pass the parameter.
Yeah, that's right.
So line card, because it's a root object, so system will create an ID for you, right? Is that?
Yeah.
I see.
Yeah, correct.
I see. Okay. Now the second question is, can you go to OCM? I can put some the OCM. There's a two part, right? So one is the OCM, like a one. It's an OCM port, right? So within a port, there's channels, right? So there should be a power, right? I forgot. Not sure. We need to go back.
The total power or the channel power?
Channel power. Channel
power, I think, is
oh, yeah, there's a typo here. Probably yeah.
Okay,
so this should be power.
Yeah, correct.
Right?
Yeah.
It's a double, so it's a power.
Yeah, that's right.
Okay. Then third question is the OTDR. So I think you should check in the YAM model, right? So then we look at the YAM model and this together, right? Does that make sense?
Yeah. So I will send the YAM model in the group first, because right now we already support the OTDR in the northbound application, such as the management framework, because we support this in the RESTconf now. But because it will spend more time to checking the OTDR in the loss boundary. But I can send out the YARN definition in the group first, and that's very much easier. Okay.
Oh, so but you can always check into the management comment, the YARN model itself, right? It will not causing any harm.
Yes, yes. I will check in the implementation and the YARN model in the management framework comment as well.
Oh, already?
Yeah.
Oh,
no,
okay,
haven't.
Okay. Oh,
I haven't.
not. Okay, yeah. That's what I'm asking. So can you check in the OTDR YARN model first, like right now? Because it will not break the build, right? Anyway, so.
Okay, sure.
Then we look at this attribute. Because again, there will be 2 layers, so I'm not sure how it works. OTDR has many ports, right? So look at here, seems there's only 1 port. Yeah.
Because we there is a technical option, because usually the OTDR have so many ports, then you can create OTDR sub ports here. Other choice, you can create 8, for example, 8 OTDR instance. So, but we choose this one because I think it's much easier.
Yeah, but all these attributes, there's only 1 port, right? So if there's
yes.
a multiple port, you still need to have some table to say that it's like a OCM. So you have, list all the port name, then also each port will have this table. The key is combined, right? Otherwise, you can only support 1. I'm not sure. Oh, you can create a many. That's what you're saying.
Yeah,
okay.
That's right. That's right. Yeah.
So now become OTDR port, actually, this table, not the OTDR, the whole OTDR.
Yes.
Okay, that's fine. Yeah, that's all. I think it's my comment on this is it's I mean very solid. Because everything is from open config, right? So there should have not many like this dispute on that, right? So it's a very good start. Yeah.
So let's jump to the alarms, because as everybody know that there's no definition in the OpenConfig YARN model to define different kinds of alarms, but these alarms are required for operating system, for OTN operating system. We defined so many, maybe more than 200, more than 200 alarms in the OTI definition, because of the line card, it can be a terminal, transponder or muxponder or line system. So the line card could generate all kinds of alarms, and also because the OTI defines it's a line card abstraction layer. So we defined these alarms to standardize the different kinds of alarms from different vendors' platform. So right now, I believe it contains 3 different kinds of alarms. One is the common, I believe is the hardware or the component alarms, such as the let me see, the temperature, such as the temperature alarms, and also some alarms for the optical port, the RX loss or low or failure, these, and also the transceivers, and also the OTN alarms, the OTN from ODO, OTO, and OTN and FlexO, and also the client. I think is a transponder alarms, and also the Gigi Ethernet alarms, ODOCN, OTN, and also the optical components alarms such as the WSSS, the EDFA, OTDR, and so on. So because there is no standard for these alarms, I think if we can make these OTI alarms working, then the application layer or the SDN controller can receive the same alarms between different vendors' device. I think I think it will be very good for the upper applications. So any feedback on these alarms?
Wei Tang, how easy would it be to add an alarm in this proposal? Because clearly, I mean, not every vendor, I mean, other vendors might have many other alarms, right, that are specific to their piece of hardware, right, that may not match what's in the list here. So what does it mean to add an alarm to this list? Can you maybe quickly walk through the workflow of what that would look like?
And I'm not sure if I can show the source code. Let me check.
Because the other option is we can make it completely opaque, right? And just have a severity and a name, right? And just let the device just provide. We can define a structure, right? Saying the severity of the alarm, the name of the alarm, right? And maybe a couple other parameters, right? And then just let the device just provide whatever it wants, right? That way you don't have to specifically define all of these, but I'm just curious.
Yeah, so we hope that we can standardize these alarms. So because so many alarms are common between different vendors. So
Yeah,
for example,
the OTN alarms I don't have a problem with. The Gigi alarms I don't have a problem with, right? Because those you can point to some standards, right, somewhere that define those alarms, right? So those are, you know, those are pretty standard, right? And so I don't have problems with that. It's really the line card alarms, right? The hardware alarms that are really going to vary from vendor to vendor, right?
Yeah. So firstly, we can define some common ones, such as the temperature, right? So maybe we can find more common alarms, which
well, even the temperature is a little tricky, right? Because you know, some devices might have multiple thermal sensors on it, right? And some vendors might choose to declare those alarms separately, right? Based on a sensor reading, right? And targeting a specific sensor, right? Instead of just a board alarm, right? So I don't think we can generalize the equipment alarms that much, because it's going to be potentially very hardware specific, right? So that's why I was kind of curious, is how does the OTI or LI deal with that, right?
So for example, the alarms, because this is just a type of alarm, there will be, when you report an alarm, there's I believe it is the instance name. For example, it's a line card, or it's a transceiver, or it's or EDFA. So they can report the same alarm type, but the instance name will be different. So so yes, for sure, there are all kinds of alarms between different vendors. So the OTI will try to summarize the common alarms here. Then if there are still the other ones which are specific for your device, for your hardware, then you can expand the OTI definition, because you know the OTI support expand attributes in the customer range. Then you can define your alarm there. Then you can report.
Okay, got it.
So sorry. I have a couple of comments. Kind of one is second to Anup. Like say at this stage of the OTI definition, right? Whether it's a good time to introduce a list of specific alarms, or probably just the the like a schema or format of it, right? That's one question. Or another approach is sort of have some category of alarms, but not. It's like say for example, OpenConfig, there's no alarm definition at all, right? Now the other open source community, like say OpenRodem, it's a semi-open. They have categories of alarm, but up to the vendor to, for example, equipment failure, communication failure, then environment, service. So those like a few categories. Then it's up to the each vendors to provide what kind of category is the detailed alarm list. That is another approach, right? So
yeah, I was kind of
mm,
thinking towards the schema approach too, right? Is instead of having this flat list, we need to define what the schema, right? Of the alarm, exactly like you said. Okay, what is the type of alarm? Is it a communication alarm? Is it a traffic alarm? Is it a equipment alarm? And what is the severity, right? Is it a service affecting, non-service affecting?
Yeah,
right?
yeah, those.
And things like that, right? So kind of defining a schema for an alarm first, maybe, and then providing the vendor flexibility to map any alarm, right, that their particular hardware supports to that schema, right?
Yeah.
Might provide the ultimate level of flexibility, right, in terms of and then we don't have to go explicitly define every one of these alarms in the LI, right? And in terms of supporting a particular vendor's equipment, that vendor would have to publish, right, what are the alarms that their particular hardware platform supports, right?
Yeah.
That was my thought, because otherwise this list is going to get really long and unwieldy, and that's
very hard to maintain.
Very hard to maintain. That's my concern. Again, maybe unwanted unwarranted concern, but
because like this vendor supported like a subset plus something, right? So it's like a hybrid. I don't think equipment will be exactly except already existing equipment running on like Ali's device, right? So exactly like this, but the other one will be, I don't think it can exactly match.
So
it's hard.
Yeah, I mean, I think listening to what Anup said, right? I was just in the same lines of thinking. So I have a schema, and then put all the different categories there, so that it is easier for maintainability as well. And then each vendor can actually use that schema itself to basically define their level of severity and those alarms as well, right? So it becomes easier for them to manage as well, right?
Yeah. So
yeah, then we can move. We can always. I mean, if more consensus reached, right? So we can go more specific. It's always
you
good.
You can do one more thing, right? Like as Rating was saying, right? So we can have the common alarms separately, and which are generic, for all the vendors, right? We can just have it if they still want it, right? Which is not going to change, and which every vendor is going to use. Just have it in this flat file or whatever is it. But at least the vendor specific stuff, we probably need to have it in a schema format so that it becomes easier for the handling of it, right? I mean, Anup, any thoughts on that? Keeping the generic stuff like this, if we need to be.
Yeah, but even the generic stuff, right? Again, we have to look through every one of these alarms, right, and figure that out, right? Is what is defined as an alarm? Yeah,
have
exactly.
the commonality.
Yeah, if we have the commonality, right? So yeah, we can look through these and see, is there some mandatory list of alarms we expect every piece of hardware to support, or something like that, right? If we can all agree on such a list, right, then it might make sense to explicitly call it out. My view is anything beyond that,
yes,
we just define the schema and leave it up to each vendor to implement whatever alarms they see fit.
Yep.
And then publish, right, to the SDN controller or whoever, right, what alarms that they support from that particular platform, right? I think that provides the most flexibility in terms of taking this forward, right? As different vendors start to implement on the on this platform, right, on this OS platform. Just a thought, Wei Tang, something to think about, I think, right? We don't need to make a decision. I'm just throwing ideas out, right?
Yeah. So one action.
So what is the Wei Tang? What is the gray, black, and the purple? I mean gray. What is difference? The black is what? Yeah, the different color. What you try to say here?
Because I think the black one I think is the common one.
Oh, okay.
I just category these in 1 minute, so maybe it's not correct. So such as the FPGA, I think these are not that common.
Correct.
The black
yeah.
one.
Yeah, but I'll give an example, like low temperature alarm. That's not very high temperature is common, right? Low is I've not seen that, on all devices, right? To say, so I think, if we go through these, I think we're going to find that there's probably a very small number, right, that we all agree on as kind of basic alarms that every device needs to support. We might get more agreement. We might get more agreement when we get to the kind of the OTN layer, right? Anything that's defined in G709 or G798, kind of alarms, right? I think everybody would agree on, right? Because those actually comes from standards documents, right? So anything related to OTN, we might be able to generally agree on it and say, yeah, these are these every device would probably support, right? So, but it's
so as an action, I will provide all the alarms definitions with the categories as you mentioned. Then I will send it out again. Then we can find out. We can pick out the common alarms first. Then we can support these alarms in the OTI first version first.
So question, just terminology in your definition of an OTI or LI alarm, is this the integrated defect or this is the raw defect? What is this exactly? Are you like, for example, we have the persistency timers, right? 2.5 seconds, kind of the standard OTN timers and stuff, right? 2.5 seconds before you report and all that. Is that all integrated before this is reported, or where is that function actually being done?
I think these alarms are generated by the line card or operating system.
Yeah, but typically those would report defects, right? Not integrated alarms, right? Line cards or ASICs, right? Typically would report a raw defect, right? Not something that's been integrated for 2.5 seconds. I'm just curious, in this definition, what would OTI be reporting up? You see my question, right? The question is, where is the alarm integration function being implemented? Is it being done within the vendor's code, or is this being done in like OLSS or some other component? Where is that function actually being done?
Or even driver, right?
Or even driver. I don't know. I'm asking. I'm not sure, right? It's not, but because when you use the term alarm, it has a meaning, right? Alarm typically means it's already been integrated, right? The persistency timer has already been run. So that's why I'm asking the question.
Yeah, what's the integration? I didn't get the question.
So typically for like OTN alarms, right? You detect a defect, you have a persistency timer that runs for, let's say, 2.5 seconds, right? After that persistency timer is done, then you report the alarm, right? And the reason for doing that is so that you don't report
have a toggle,
toggling defects, right? And cause a defect storm in the network, right? So typically for OTN, and this I think comes from SONiC SDH world, right? You typically integrate the alarm for 2.5 seconds. That's called a persistency timer, right? And then you report it. And then for clearing the alarm, you have typically a 10-second timer, right? So you wait for 10 seconds for that defect to clear, or that alarm, that condition to clear before you actually report the clear of the alarm to the external management systems, right? So my question is, when you say alarm here, is the expectation that all of that persistency, soaking timers, clear timers, all of that is implemented within the vendor driver code or line card code, or is that done at an upper layer?
Yeah, it's I think it's in the line card operating system, because so right now OTI only defined the callback function for the line card for the OTI to report alarm. So the alarm can be generated or cleared. Then the updater just need to save in the database or save in the history database if the alarm was cleared.
Okay,
But
so you're
this
expecting,
logic
yeah.
is
Okay, so you're expecting all of that logic, the persistency timers. I don't remember the standards where that comes for OTN, but the exact standards number. But
Yes. So Anu, quick question. I think this should be in the line card, right? Because otherwise you'll be flooding, right? Because if there is a toggling which is happening between the alarm, if you're not doing it in the line card based on the persistent timer, what you're talking about, right? Then you'll be basically updating either the database or something continuously, right? Because of this toggle.
no,
And how do you basically stop this? You will not know how to stop it also, right?
yeah, that's why I was asking the question, right?
Yeah, correct. So I think
so
it needs
I just
to be
wanted to make
in the line card only.
yeah, that's fine. I mean, yeah, I just wanted to make sure that just that would be done in the line card, right? Because the name alarm is sometimes used loosely, right, in definitions, and I just wanted to lock it down, right? That alarm really means an integrated defect, right? And that the integration is actually done within the line card, right? So I just wanted to confirm that.
Absolutely. Yeah.
Okay. All right. Okay, that sounds good. Thanks, Wei.
Yeah, then the follow-up question will be we so all these alarm will be visible to the northbound, right? So the name OTI or lie is just a syncd event, right? However, all these alarm will eventually send out to the northbound. That's the expectation here, right?
Yeah. So
Directly.
Well, not everything, right? Because, like, for example, bitpaid is not an alarm, right? SM bitpaid is not an alarm. That's a PM counter.
Yeah, this is another. There's some distinction needed to be made here, right?
Yeah. So yeah, because typically you wouldn't raise bitpaid as an alarm. Bitpaid is a counter, right? It's a PM counter. BEI, similar thing, right? That's a backward error indication. You wouldn't typically report that as an alarm. Out of frame, you would never report as an alarm, right? Because what is actually reported is a loss of frame, which is the integrated form of out of frame, right?
Sure.
So that's why I was getting slightly confused, because what I see here, some look like raw defects to me, some look like counters, some look like soaked alarms, which is why I was asking that question initially, right? It seems to be a mix of things in here, and it's not clear to me.
Probably at least we need to classify that first, right? As you say.
Yeah,
right?
yeah, exactly.
Otherwise, it's going to be a problem, right? We'll be cycling in this. Maybe we can have another column, and then maybe we can update that as well, right? With the details.
And this was the one of the reasons earlier I was saying, maybe this all needs to be in a schema, right? Just define the schema, let the vendor deal with it, right? Because then this becomes a non-issue, right, from the perspective of this working group, right?
That's correct. Yeah.
Let the vendors, the OTI definition would be, we define a schema where you can use to report integrated defects or alarms, right?
Yes.
And then, using that schema, right, anybody can report whatever they want, right, depending on what the vendor supports. So
and then next step probably have some common small set, right?
Yeah, there might be some small set. Yeah, my feeling is, as we go through these, we're gonna say there's only a very tiny bit that is gonna be common, right?
We'll keep cycling this for a longer time then.
That's what I was wondering, is that should we just short circuit it and just define a schema instead, and just say leave it up to each vendor to define whatever alarms their particular platform is capable of supporting, right?
And do we then, if you're leaving it to the vendors, right, using a schema, do you think that the things which you said about one being a counter, other being an alarm, other being an like regarding LOF and things like that, right? Do we need to basically classify that still, or is it not required?
No, it wouldn't be required, because now it's up to the vendor to define exactly what alarms they would do, they would support, right?
Got it. Yeah.
Especially if we're saying the only thing we're using this for, and Wei Tang, you can confirm this, but if you're saying the only thing this is used for is just to write it to Redis so that we can send a netconf notification, right, through the management layer, if that is the only thing this is used for, then I would agree that just define a schema and let each vendor populate whatever they want into the DB, right? Just define the schema in the DB and just populate it whatever alarms any vendor wants to put in there, right? But if this is used for something else, you know, if OLSS or somebody else is using some of these indicators, then it might make a difference, right?
But tell me one thing, Anup, I have a clarification on your statement now. So whatever the vendors are basically classifying based on the schema, whatever the alarms or whether it is counters or whatever, right? Then at least the Redis database has to be a common database, meaning a common way of applying all these schema data, right? So that it can be interpreted in the right way for the
yeah, exactly. I assume that there'll be a table in the database with the schema that matches, right? Whatever we want the northbound notification to look like, right? You know, out of the device.
That will be taken by the northbound interface exactly from the table. It will translate and then send it out. Right? Otherwise, it's a real nightmare if everybody is starting to put their own way of doing things.
Yeah, of course. Yeah, that's what I'm saying. We need agreement on the schema, right?
Yeah.
Both for the LI and the OTI and the database, right? Exactly what this is going to look like.
Exactly.
And once we agree on that, I think the rest of it, I think we just leave it up to the vendors, right? To populate those tables whichever way they see fit, right?
Yeah, at this stage especially. So when we introduce something new, right, you want to make it tight and small, or you want to kind of expand it too much, so you lose the flexibility later.
Yeah, correct.
The fluctuate,
Doing it the right way in the beginning itself, rather than like trying to recorrect it sometime at the end, right?
It's a proposal we should think through, right? Let's all think through it, right? And we don't need to make a decision right here now. We just started talking about this topic, so I think it's something to maybe just mull over, right? And then we can come back next meeting, right? And hear other thoughts, right? And I'm sure other folks.
I will provide the schema and all the definitions of these alarms. Then I think when we implement these alarms in the source code, I believe we will add some annotation for each alarms for these common alarms. I think these are okay. So
another feedback we take is that temperature related or equipment related is handled in the SONiC platform, right? So they have a sensor temperature daemon specifically to handle those environment things. So whether should it be in OTI or not, I'm not sure. So one principle we try to achieve is OTI is only the optical feature, core feature, right? Surrounding for that. But generic like temperature, for example, they already in the platform, SONiC platform. So that's another feedback.
Okay, so if the alarm there's we are not sure that, then we can move it out from the first.
Okay.
Now I think that's all for the OTI definition. Then because I want to update the progress on the high level design, and I made a summary here because we had a rounds of discussion in the email thread with the groups. I think right now we made a decision and we think that we can keep moving with the option 1, which is already discussed in the past meeting. So option 1 means that we will introduce 2 new OLSS and syncd containers for the OTN, and these are the, I think this is summarized from the high level design, which is already in the GitHub. I just I draw some pictures, wanted to make sure.
Yeah, there's a typo written here. Platform OTN. It's like a PI. What I see. Oh, it's a lowercase. I'm not sure. In the diagram, the green line below the green line.
Yeah, that's a typo. It's a PIA. It should be PLA. So
Yeah, it should be in two places, one on the right and one on the left
the
as well.
left as well.
Both places, I think. That's a small typo, I think.
Yeah, that's a small typo.
Okay.
No big deal.
Yeah. Yeah.
Sure, how we can implement the option one. We give us some examples. Our goal is that the SONiC OTN can support this. So if it's a switch or is a ASIC vendor, or optionally you can choose a lot, then these are the, yeah. Jimmy, are you talking? Yeah. Okay.
I think
so then
there's a
if it's
lag
a
in
switch, then you can
network.
make, what's that?
I think there was a lag in the network. We lost you and then again we got you back. Can you hear us?
Yes, but
Yeah, go ahead and now speak.
Okay.
Wait, Tang, your audio dropped for a while, so we
Yeah,
missed.
that's what I said.
We missed some of what you were saying, and then it finally caught up. So.
Okay. Because my network maybe is not that good.
Yeah.
Then if it's an OTN, then we will create. So then the platform will be an OTN vendor. So here is the list of OTN vendors. So we add the OT here, OT slash here. Then we can use this prefix to distinguish that we are making an OTN device. So this is how we can generate these binaries for different kinds of devices. Then, so there will be, depends on the target platform, then we can generate a platform OTN toggle in the building system. If this toggle is off, then it's a pure switch or is a router, the original SONiC. So all the OTN features will be disabled. It's an original SONiC for switch and router. But if we are making a platform is OTN vendor, then this feature toggle will be on. Then all the OTN features will be enabled, and some of SONiC IP features will be disabled. So in this picture, you will see that these gray blocks will be disabled, which are not required in the OTN device. And some new OTN containers, and some existing SONiC containers will add OTN plug-in here and the CLI. I think that's the plan.
Hey, Wei Tang, one question. Hey, Wei Tang.
Yeah.
So I mean,
yeah.
even for the OTN device, don't we need the SWSS and SYNC-D, for example, to manage the DCN ports on the device, which might be going through a layer 3 switch?
We need that. That's the reason my plan was we need to have all those things as well, right?
Yeah, so I think even in the OTN platform, you need SWSS and SYNC-D running, because how else do you manage the DCN ports, right? Or any Ethernet ports that the device might have for any sort of use, right? Whether it's for DCN or something else. Supporting all kinds of layer 3 functions, right?
Yeah, I think there's a conflict here. So because if you want SWSS and the SYNC-D for the IP for the router, then you need to choose the platform. For example, the Broadcom platform, right? And then you also need a platform for the OTN. I don't know how to do that. Maybe we need.
No. Wei Tang, I think, right, the platform, if you think today for SONiC, you have only platform which is Broadcom. Under Broadcom, for the same chipsets, right? Like for Trident or Tomahawk or things like that, right? You will have different vendors under platform under Broadcom. So they will have Cisco, they will have Alibaba, they will have Juniper, they will have Dell, like that. So your platform will be what is your ASIC platform, right? So you basically use that, and underneath that you will have all these different vendor names. That's how it is. And you have basically either ARM, which is ARM64 architecture, or x86. So you could build whichever way. Currently, if you think about SONiC, in x86, you have for different vendors building SONiC, with platforms being Broadcom and a Broadcom, and it's just one image, SONiC Broadcom.bin. That's about it. So any vendor, whether it is Dell, Juniper, Cisco, whoever is it, picks it up, and it'll, based on the hardware SKU, it'll figure out, okay, which vendor is it, and then it'll basically pick up the right things to basically download and program and things like that, right? It'll pick up the right SDK versions and things like that as well, and libsci version and everything, right? So now, with respect to ARM, if you think about ARM, there's not much vendors there. Only Marvel is there as of today, and Marvel's only ARM is there, and then there is Centec as well, and Centec also uses Marvel chips, I think. So they also have their own ARM64. They build their own ARM64, right? But there's nothing other than Marvel chipset, right, which is ARM. There's no other NXP or something is not there as of today. So if somebody's going to introduce, then they're going to introduce. So it should be probably under the platform vendor like Broadcom, because our DCN ports, if they are using Broadcom chipset for layer 2, layer 3, right, and layer 3 switches for Broadcom, then we can put it under Broadcom itself, and that will take care of your DCN and other things for Ethernet using SWSS, and you can have your platform for OTN as well, right?
Yeah, so if we have both OTN and ASIC, so I'm not sure how we can make config here. So maybe we need to make config the platform. We need two platforms, right? One is OTN, one is ASIC, right? Is it right?
Why do you need OTN is what I'm thinking, right? So no, when you do Broadcom, like okay, let me take a step back. Under ASIC vendor Broadcom itself, right, you will have multiple vendors. If you see today, there are multiple vendors, right? Underneath that, we can have Alibaba, we can have XYZ, we can have Cisco is already there, Infinera we can put, and all these things. Molex can be there, and that will basically build, and there will be a hardware SKU unique for each of these, and based on that, it will basically know what to build and how to build and things like that. That's how the build environment is there in SONiC. You don't want to do different for two different make configure, I think.
So in the SONiC, there's a platform. Platform basically is the ASIC, right? So under platform, there's a devices. These are hardware vendors. Hardware vendors.
Okay, under platform, you're right. There are vendors under platform, and there is another thing called devices. Under devices, you will have all the different vendor names as well there. There, they'll put their whatever is required there. So there are two different places you need to basically look at. One is under platform. There'll be vendors like Broadcom. Underneath, if you go under Broadcom, you can see all those things. And then under devices also there'll be something. Maybe if you go to GitHub, you'll be able to see that.
I think theoretically, Harash, it's just the platform, then is a device. So they just group all the devices under one vendor.
No,
so, I don't think there's a concept of hardware vendor and a platform. I don't know, I'm not sure.
No, can you go to github.com SONiC? Wait.
Platform. Platform.
No. Hold on. Let's go to SONiC. Right? Let's just no. Let's go to SONiC first. SONiC build image. Go to SONiC. Yeah. Click on that. Now what you do is like go down. Go to click on platform.
Wait a minute. This is because we remove all the.
They already removed all the ASIC.
Don't worry. No, that's fine. Still, it's okay. Yeah. Okay. Now go. No, not here. You go back to the original, right? Go to device. Yeah. So
this is yours, right? This is yours.
This is yours, right? So under device, you have these two. Now, if you go if you go to the original SONiC, right, then I will show you clearly. If you go to the original SONiC, we can just see how it is. Yeah. Now go to device. So if you see under device, yeah, you'll see all these things named, right? Acton, Alpha Networks, and Arista, Barefoot, and then there's Broadcom, Celesticus, and all these people, right? Juniper is there, Immunotech, Ingrasys, everybody. Dell is also there, right? If you click under Broadcom, you will see these are all related to Broadcom, right? It says, say, Broadcom Common and things like this related to Broadcom. Now you go back to platform now, right? Go back to platform, right? The same thing, go down a little bit. If you go down a little bit, you'll go to platform. Yeah, click on platform. Now you go to Broadcom. Right? If you go to, yeah, click on Broadcom. So if you see under Broadcom, there'll be all platform modules for each of those different vendors like Alpha Networks, Acton, Dell, Celestica, Intrasys. Everybody will have their own stuff put in there. That's what I'm talking about. So you will have underneath that, and all the SI modules and everything will be there here.
I think, Harash, the device, even in the device list, there will point to one platform.
No, they will. But I'm saying when you build based on, see, as Anup was asking you a question, right? So if we have a box with Broadcom chipset, right? And your DCN is all using Broadcom, right? Then how do you basically tie it up is what he was asking. If you're basically removing the SWSs and things like that, right? How do you basically tie it up, right? In SONiC, this is how they do it. You have a device, you have a platform, and a Broadcom, you have basically all these things. So that is basically taking care of all these things. But if you remove SWSs now, how do you basically link all these things now? And if you're building it, if you build it based on Broadcom, right, the chipset, then it becomes easier also, right, and a platform.
No, we don't need a Broadcom anymore. If we create a new platform.
No, but Jimmy, the question though, you know, it's we just take it at one level, right? The question is, if I need to manage a hardware platform that has a Broadcom layer 3 switch, and I need to support some layer 3 functionality, for example, for a DCN port, right? On an OTN platform, which containers will be responsible for supporting that function, right? It's not going to be OLSS, right? Because OLSS knows nothing about Broadcom devices, layer 3 functions, right? The containers that know that capability today are the SWSS and SYNCD. So which in my mind implies that even on an OTN box, those containers need to be running.
Correct.
Because how else do you manage your DCN functions on a platform that has a Broadcom layer 3 device on?
Okay, so my answer for that is assume our OTN device has no Broadcom chip, right? So we still need L2, L3 function on the DCN port, right?
Correct.
So it will just, you don't need the SWSS and the SYNCD original SONiC container here to support L2 and L3 still. Basically, BGP is just FRR. It talk to the Linux kernel directly.
No, but it needs some ASIC to be programming.
No,
also,
you don't
right?
need a. You assume there's no ASIC, right?
No, but how do you program routes?
How do you program it?
Well, the BGP container itself.
No, BGP container doesn't program the ASIC directly. It goes through readers only.
No ASIC, right? That's my assumption.
No, but that's a wrong assumption, Jimmy.
Exactly.
Right? Because if you're actually programming routes into or tables into the Broadcom, how do you get that done, right? We have devices that
assume
do that.
there's, or you mean the OTN device has a Broadcom chip?
Yeah, layer 3 switch. It has a layer 3 switch on it, right?
It has
layer 3 switch for what? For the DCN?
Yeah, for the DCN.
Oh, okay. I see what you mean. But in our equipment, we don't have L3 is all software.
Yeah. See, we have devices that have true layer 3 switches in them, right?
I see.
So that's why I was asking that question about how can we say we're getting rid of SWSS when all that capability is handled through SWSS.
Okay, understand.
For example, in your equipment, your ASIC is a Broadcom, right? Then you also run the OTN containers, both, right?
Correct. Yeah, I mean that's my thinking right now, right? Is that if you had a device that had a true layer 3 switch or DCN, layer 3 functionality, and it happened to be a device that supports OTN capability, my feeling is you need both sets of containers.
Correct. That was our design.
Right? Although they are not even for the service.
They're not for the service. They're purely to manage the management side of things, right?
I understand.
You know,
so in our case, everything is a Linux So
Yeah,
yeah.
I agree with you. If you don't have a true
If you
layer
don't-
3 switch, I fully agree with you. You don't need
Okay,
SWSS and
okay,
SYNC-T.
okay.
Yeah. In
Understand.
that case, you can do it from software itself. You don't need any-
Just go
Yeah,
straight
we
to Linux.
everything
Right?
we do in Linux kernel, so
That's
we
correct.
don't need.
Yeah, all netlink
I
and
think-
everything, you can get it. Yeah, that's true. Yeah.
Yeah, I think the one idea pop up in my mind is that this platform will be I think it will be a list. So for example, is a list with ASIC vendor and OTN vendor. So for example, you make config platform, Broadcom, and then OTN Infilera.
Yep.
Then it will keep both of these different containers.
Yeah, that's
No,
my thinking.
I
I'm not sure
understand
if this
the
algorithm support that.
Harash your original option 3, right?
Uh-huh.
Now
Yeah,
I
that's
understand
what-
the background of that. So you
Oh,
want
okay, no problem. No problem. Yeah, that's the reason I brought up that, and I think the that's where I had the OT synced as well as a separate container.
Okay,
so that
okay,
it
okay.
takes
Now
care
I
of it. I
understand
didn't
why
mind.
you saying that.
Yeah. Okay. Yeah. No problem. No problem. Yeah. Yeah.
So I'm not sure. I'm not sure how we can do that because
tough.
Yeah, it will be not easy to do that. I will do some investigation to see if we can support both ASIC and OTN.
Yeah, we can. Yeah, we can think about. I mean, I think
We can, unless you go back to option 1. That's one thing. But
you go to the document.
Huh? Option 1, right? We basically add stuff into original SWN.
No.
Not go back there.
No, Jimmy. Let's not go back. We are all
certain.
concluding on something now.
Well, again, guys, we don't need to solve the problem today. We're out of time anyways, right? But I think this is just something we need to think through because that's not an uncommon thing, right? To have a OTN device that has a layer 3 switch for DCN capability. I don't think that's a really foreign concept, right? I think that a lot of OTN devices have that.
Yep.
So I think that is a configuration that we have to support.
That's correct.
So I think we just need to think through what would be the best way to make that happen, right? I don't think we should rehash the whole one container versus 2 thing anymore, right? Because then we're just starting in ground zero again, right? I wouldn't.
No, I think at least
let's not go there.
Yeah,
Now.
one thing, Anup and Harash, can you do everything in the BGP container called the Broadcom chip driver? You don't want to do that?
No. The BGP container is open source FRR container there, or you could even go to Go BGP. You have an option to basically do that. You will not be going and meddling over there. No.
Okay.
You don't want to do that. Yeah.
So
I mean, even if you do that, right? Okay. So what are you going to gain? You're still going to basically update. You have to somehow update the Redis database for the SYNC-T to basically pick up that. If you're trying to bypass the SWSS, so you're trying to say whatever was SWSS functionality which was doing for the DCN, now you're basically trying to move it to the BGP container, right? That's what you're saying, right? Whether it is possible to do that.
DCN probably
in general,
not that complicated compared to all these
no,
things.
I understand. And I understand, Jimmy, but I'm saying that is more. It will be more of like a hack or something like that. I probably don't like that solution.
Okay.
Yeah.
It's something we can just kind of think through, right? And we're not going to solve it here, I don't think, right?
I know.
So offline we can think through it and see,
sure.
How do we support that configuration, right?
So let's jump to the these are the how we can disable these features, which containers lead a OTN plugin, and which new OTN services we introduced. So 3 different strategies. Yeah.
So
then the last
on the Redis server, don't you need some new tables for optical?
Right now I'm not sure. So I hope that we don't touch the Redis logic instance. So
you're not touching the logical instance. You will not be touching the logical instance. You will probably try to create tables, right? For just OTN, if it is specific, you don't
Yeah,
want
yeah,
to.
yeah. Yes,
That way,
correct.
it becomes easier to maintain. So
No,
Yeah,
there's a issue here. I mentioned in the email, right? So SWS as a common is the place where all the tables are defined, right?
yeah.
So you have to add an optical table inside of this SWS as common, which is a very low level library.
Yeah,
So,
sure. We agree that. Yeah.
mhm.
Yeah.
Okay. So this again, you will combine all the code together.
Yeah. So we will not introduce new Redis logic database. We just add OTN tables.
Table name, right? At least you need an edit to that.
Yeah, correct.
Okay.
Maybe we will reuse some logical database instance as the history database. That's the original plan. Yeah. So here's an overview on this roadmap. So because then we can see our plan. So in Q1 to 2023, we set up the group and kick off the group. Then we spend 2 quarters to review, to introduce the Alibaba and SONiC source code. We open sourced. Then we have rounds of framework introduction. Then we have discussions on this OTN definition and high level design. Now we are here. So next, I think we can start to submit our source code to the SONiC master. So I think we will spend more than 3 quarters here. So we are some containers we will add OTN plugin, and we will introduce new OTN services. Maybe we need disable some or keep these containers for OTN. So we will implement this and start to submit this source code into the OTN masters. And then we will do this because we don't have the real hardware. Then I think we can support this on a virtual device. Then we submit this and make the virtual device working on the SONiC master branch. Lastly, then the real vendors can implement their device on the SONiC OTN implementation. That's the plan. Does it make sense? So any comments?
Yeah, I think so. Just the one comment is the submit to SONiC master, right? So this process, there's a 2 parts. One is we introduce the 3 new repos, right? Then also we are going to modify maybe 5 or 6 repos, right? So what is the sequence you think we should push in the new repo first, or that's my thoughts. We probably should push the new repo first, like OTI, SONiC, OTI, Redis, then OLSS, because there will be no interference with other, right? Then we start pushing the common, the one we are changing.
Yeah. So yeah, I agree. So first, because these one are easier to push to the OTN,
if they accept.
Yeah, at the same time, because how we can plug in the OTN features in this existing container, I think right now we don't have a clear implementation plan. So I think in the parallelly we can start to do some investigation and high-level design to implement the particular
repo by
containers.
Repo by repo.
Yeah, right. Yeah, repo by repo.
Okay.
Yeah. So
LLDP, just a quick question. Wei-Tan, why we need to change LLDP container?
I put it here because I'm not sure.
Okay.
Not very sure, because on the OSC we maybe we support ILDP, and also the transponder client ports support ILDP.
Oh,
There are probably some OTN specific functionalities.
it's a generic
So,
in my mind.
this one is
L2.
okay.
Yeah. I mean, LLDP is like L2, right? As Jimmy says, right? It is generic, right? So what is specific there we need to do for OTN? That's a good point.
Yeah.
I don't think there is anything specific in LLDP, right?
Yeah. So for example, in Alibaba, they might need get the point, your AZ point to point, the point Z power, the power, the optical power, even the, how to say that, even the management of network is not working. So yeah, I think there's some private requirement.
Oh, so is it like kind of a proprietary stuff which we are doing here? Because if it is vendor specific and proprietary, right, then you don't want.
Yes. So I think we can remove this.
You should remove that. LDP is a standard. You cannot add your proprietary stuff in
Exactly. Yeah, that's what I was telling.
Okay. We can remove this. So if
and what about telemetry? Telemetry also, you have something there which you're basically streaming specific configuration or something.
So for example, the management framework we support the OTN components open config YAM model, right? Then in the telemetry, so currently this container cannot support all these features. We made some enhancement in this, such as how to say that, because I don't know how to, maybe when you jump to the introduction we provide.
Sure. Not just
for example, yeah. So for example, we because you need to subscribe different trees. For example, the transceiver, right? And the original telemetry container cannot support that, because the spin controller just subscribe, for example, the component / transceiver. Then the telemetry container should report all the status or statics for the Pacific, for all the transceivers, for example. So this is one to many. So one subscribe path, but many paths. So one to many report.
Yeah. So wait, they don't have good filter support. You're saying, right? They don't have good filter support.
Yeah.
Okay.
Yeah. So I think these are containers we need a more high-level design to, because right now our implementation didn't considering merge it back. So right now we need some high-level design, and I think we need some, we call for volunteers to do these kind of task to support this OTN plugin in original SONiC containers. That's the plan.
That's good. So I think this this blue square we should consider as an enhancement of the current container, right?
Yeah.
We should. Yeah. So then it will be good for the large community too, because some feature they don't have, we add, right? And also, not only for OTN, but also can be used by the other platform. That would be good.
Okay. Yeah, I think that's all I have. I think we run out of time. So any other comments, questions?
Yeah, so just so we can just start. I mean, this is a step-by-step thing. So next thing is, I mean, two thread, right? One is really at this point we should contact the SONiC, like a technical steering team to share what we try to achieve. we currently is like just working by ourselves. Nobody even thought of it. So I think we need to catch up on that side. And then second, we can start to divide these tasks to based on the company or whatever team to yeah.
Yeah, I agree.
Mm.
Yeah,
Jimmy, I think we can probably for next the SONiC has TSC meeting. I think once a month. Probably we can update them the progress we made on this project next time.
Yeah. Songjin, what do you say? 1 month? What?
They have SONiC has a TSC
meeting. I see. It's we should plan this, our activities at least. Yeah. Then second thing is any idea of the format of OTI like spec? So what kind of format the OTI spec should be in? Psi is a markdown file basically.
I think generally they follow Markdown, if I'm not wrong.
Okay.
In SONiC mostly. So it's all only Markdown only.
Okay, so probably we should prepare that. You already have one version of that, right? So probably can modify on top of that.
Okay, sure.
Okay, that's all.
Yeah, Chunji, I think that's all for the meeting, I believe.
Okay, it's good.
Yep.
Thank you, everyone.
Thank you.
Okay, thanks everyone.
Yeah, thank you.
Bye.
Okay, bye-bye.